Today we're going to discuss a specific type or types of exponential functions, specifically growth and decay. So I have two of them listed right in front of us here. The first is the growth equation, and the standard growth equation is the final amount, or y, is equal to some initial amount, a, times the quantity of 1 plus r. R is the rate of growth, or the rate of change, and raised to the t power. Now what signifies growth in this case is we're adding the rate to the 1. You'll see below that when we talk about exponential decay or decreasing, we have the original amount, the initial amount, same as before, but the difference is we're subtracting the rate from 1, and that gives us a decay. Now, other than these two growth and decay equations, I have an investment type of growth equation, and it's called a compound interest equation. And basically what compound interest is you take and put money in a bank and they give you money for actually keeping their money with them. And they give you a little bit every time, and when they give you that money, they say, we'll give you a little bit more for every period of time that you keep it in here. And let's talk about the equation. The amount that you currently have in the bank, or final amount, let's say, is given by A. P is the initial amount invested, and then we've got the quantity of 1 plus R is the rate you invest at, and N is the number of times it's invested over the course of a year. So if I invest something annually, that's once a year, and N would be 1. If I invest something semi-annually, that's twice a year, and that would mean N equals 2. If I invest quarterly, that would mean 4 times a year, N equals 4, etc., etc. And this is all raised to the N times T power, where T is the total number of years. All right? So let's go through and identify which equation to use and solve some problems. So in 2008, we know a school district had about 4,500 students. There's a growth of 0.15%, and we want to know what the population is going to be in 2014. So first of all, we know this is a growth. It's not an interest problem. So we know the formula we're going to use is this one right here. And we have our initial amount. We're looking for our final amount. The initial amount is 4,500. We know our rate is 0.15%. Now you have to remember 0.15% would be 0.0015. And how many years do we have from 2008 to 2014? It's a total of 6 years. So with this, we turn it into a calculator problem. And the way I'd like to do these is I do what's in parentheses first. So I say 1 plus 0.0015. Find out what that equals. Raise it to the 6th power. Find out what that equals. And then multiply by 4,500. And that gets us approximately 4,540. So we've gone up by 40 people. And that's equal to y. Again, we use this formula because it's a growth and because there's no compound interest. Moving to the next problem, we read that you've got a recession and the charity found that its donations dropped by a specific percentage. So there's a rate. For the recession, we had donations of 390,000, and we want to estimate the donations after 5 years. So, once again, it doesn't seem that there's any compound interest, so we're going to use the same equation. But this time we have a decay because things are dropping. We have an initial amount of 390,000. 1, and instead of plus we use minus this time. 1.1%, 0.011 raised to the, gives us 5 years, so we pop that in. Turns into a calculator problem, and we end up with a quantity of 369,016.74. So let's look at our next example. So we notice when Lucy was 10, father invests $2,500 at a rate of 8%. Here's the kicker. It's compounded semi-annually. So we know that this is compound interest, not only because it's in the problem, but because we labeled it that way. And when she turns 18, the money's going to help her buy a car. And what amount will she get from the investment when she's 18? So we have an initial amount invested of $2,500. And we take 1 plus the rate, which is 8%, so that's 0.08. It's compounded semi-annually, so n corresponds to the number of times it's compounded in a year. Semi means 2, so twice. And then we raise that to the n, which is 2, times the number of years, from 10 to 18, so it's 8 years. So what we have is 2,500 times 1 plus 0.08 over 2 raised to the 16th power. Again, I'll show you how I'd use a calculator to get this problem done. I would take 0.08, divide that by 2, find out what that equals, add 1 to that, find out what that equals, raise it to the 16th power, and multiply by 2,500. And that's equal to 4,682.45. So by keeping the money in the bank, we earn about $2,000 in interest over an 8-year period. Let's do another problem. All right, another individual is born. We invest $1,000 and we compound interest at 7%. This time we're compounding annually, and when she turns 18, it's going to help with college, and we want to know how much you're going to get when you're 18. So we're investing for a longer period of time. In this case, initial investment $1,000. 1 plus the rate was 7%, 0.07. It's compounded annually, so that's only once a year. And we do it for a total of 18 years, so that's 1 times 18. We pop that in our calculator, and we end up with 3,379.93 cents. Right? That's all we've got. Do me a favor and write your lesson summary, solve the problems below, and we'll discuss this more tomorrow.